Welcome to the lesson on 6.1, properties of logarithms. The main question we'll be dealing with is, what are the properties of logarithms? We'll be investigating the properties of logarithms. Why don't you pause the video and you try these questions, guys, by plugging this into the calculator. So we're back. The values that I got was 0.566 and 2.303, 4.343. Now looking at these decimal values, we can find the relationship between these two expressions, right? And I see that log 10 divided by e, this common log, has 0.566, and this one has it. Okay, so it looks like there's some way to express this differently. How about log base 10? 2.303 is this one. So it's 1 over log base e. Okay. How about log base 10, the e to the 10, 4.343, and I got 10 log base e. Okay. How about this one? Log base 10, 1.434. I notice that is same as 1 plus log base e. So basically what we're going to do is we're going to learn some bunch of properties that allows us to transform, change this expression into this one and vice versa. Okay. But before we begin though, I'd like to just check that we did this correctly for the set A. So check set A. So what you need to do is this one right there. So that expression is base 10, isn't it? So if you put that in terms of exponential form, that means 10 to the power of 0.566 will ultimately would have to equal to 10 over e. But when you put that into the calculator, I got 3.681, which is approximately equal to this. Put that in the calculator, you'll find that it's about that. Obviously, because we stopped at 3 decimal places, the value is not going to be exactly the same, but it's very, very close. Okay, and you do the same thing for these 3. Why don't you pause and you try? Okay, so if you did it, what you should have gotten is that this is e to the 2.303, which is approximately 10.004, and that's approximately equal to 10. Check. And the next one was 10.4343. That's approximately 22029, and that's approximately e to the 10. Because we have so many decimal values here, there's no need for you to go to the decimal. So this last one is base 10, so that's 10 to the 1.434. That was approximately 27.164, and that definitely was about 10e. So check. Check. So I guess you know what I'm going to do, right? I'm going to ask you guys to, you know what? I don't think it's necessary to check set B, but this is good. So big smiley face. So we'll be addressing this question in class. So that's for discussion in class. But these are the rules that you need to know. Right here, guys. So we know that for any positive numbers, a, m, n, and b, where b is not equal to 1 and c is not equal to 1, the following property holds. That log base b to the bm is m. Now, there's a really easy way to check that out. Convert that into the exponential form. What do you get? Basically, that says that's b to the m is equal to whatever's inside, right? The inside is b to the m. That's why log base b of b to the m is m. So it's almost like canceling, right? And another way to think about that is the exponential expression over here and the log of the same base are inverses. So they undo each other. So that makes perfect sense, right? And this one is 0 because I could express that as what? A log of base b of 1 equal to 0 is I could express that as log base b of b to the 0, right? Then they cancel, quote unquote, and it becomes that. And this right here is just first power. log base b of b is log base b of b to the first, so they quote-unquote cancel out and becomes 1. We're not going to do any proof on this one for the following this one over here. If you wish, we could maybe go over maybe a couple in class, but we'll just take it as face value. Log base b of the product of the two value is log base b of the sum of the log of the two. The quotient rule says m divided by b of the log b is the difference of the two. Now this one is a power, goes into the front. The quick way to think about this is if you have log base b of m to the n, you're doing log base b of m times dot 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 m, the n of them, right? Because it's multiplication that we'll be adding here using this property, and there are n of them. When you add the same thing m of them n times over, you simply multiply. So that's why we have a in the front. We just add a whole bunch of them. Okay, and then there's a change of base property. This is what allows you to, let's say, find log base 2. Because in your calculator you don't have it, right? So we need this property. So log base c of a is log base of any base a, and log base b of c. When I say any, it can't be 1. It has to be positive and cannot be 1. All right, so that's a quick rundown of the property of logarithms. Let's do a couple of problems, guys. So how do I do this? Well, if you're subtracting according to the quotient rule, quotient property says that if you're subtracting it, we could actually divide these two values, log base 3 of 27 over 81. And that simplifies to 9 goes into the, hold on. Yeah, 27 goes into 81 3 times. So that's log base 3 of 1/3. Now, using the rule that we just learned earlier, log base b of b to the, let's say, k is k. Can I express this 1/3 in terms of base 3? The answer is definitely yes. Of -1, therefore, this is equal to -1. Because log base 3 and 3, base 3, cancels. Now let's check out how do I do this. Well, we could use this value over here, right? So let's use this one. Log base 3 of 1/3, we're claiming is -1/3. Sorry, it's -1. And the way we check them is to convert them into the exponential form. And that is 3 to the power of -1. Is that equal to this, 1/3? And that is equal to 1/3. Yes, it is. Check. One more. This one. According to the rules, when you add them, we could actually use a product rule. Product property, I believe that's what the book calls it. Product property of logarithms. So of the same base, logarithm of base 5, we can multiply these two values, 1/25 and 625. That's 5 squared, and I believe this is 5 to the 4th power. When you multiply these two together, it's log of base 5 of 25. Using this rule right there, can we express 25 in terms of base 5? Yes, it's 5 squared. So that becomes 2. How do I check this? Well, I guess that's, I believe the way the book did it is that we start from this process. Log base 5 of 25, is that 2? Well, you could convert that into exponential form, which is 5 squared is 25. Is this true? It is, and we check them off. If you want to go one step further, you could actually start from the very beginning, actually, right? Because another way to check it is to do a different way, right? So log base 5 of 1/25 plus log base 5 of 625. In this particular case, the 1/25 could be written as 5 to the -2. And that could be written as 5 to the 4th. But this 2 cancels, so this -2, that quote unquote cancels again, which becomes 4. So answer is 2. I got the same answer, doing it 2 different ways. And chances are that is correct. Okay? So we do have a few more problems after this, but this should be enough for tonight. So I'll see you tomorrow, guys. Have a good night.